For example 1, we want to determine whether the series converges or diverges. I want to use a comparison test. So I want to compare ln k over k with 1 over k, since 1 over k is the harmonic series. And you can see that ln k over k is greater than 1 over k for all k greater or equal to 3. Hopefully you can see that ln k is greater than 1 for all k greater or equal to 3. Therefore, we know that the harmonic series, which is the p series and p equals to 1 for harmonic, the harmonic series is divergent. Therefore, this series diverges. I can put I can put k equals to 3 for now, and this is divergent because of the harmonic series, because we compare with the harmonic series, and the harmonic series is divergent. Now notice that even though I put k equals to 1, it's just 2 more terms when we start with k equals to 1 instead of 3. This one is going to be divergent as well because finite number of terms really doesn't affect the convergence or divergence of the series. For this series, I want to use the limit comparison test. So if I want to use the limit comparison test, I have to take the limit. So a sub n is going to be n plus 1, n to the 9th power plus n. That's our original series, and the one we want to compare with is going to be 1 over n to the 8th power. So if I take the limit and approaches infinity, a sub n over b sub n plus 1 over n to the 9th plus n. And then I'm gonna divide by b sub n. So that's just multiplied by the reciprocal. So n sub n is gonna be up here. I can just factor out the n on the bottom here. So I ended up with n plus 1, n to the 8th power over n to the 8th power plus 1. I can simplify it. So we ended up with n to the 8th power plus n to the 7th power. On the bottom, we have n to the 8th power plus 1. Because I cancel this n right here with the n sub 8. Now we're going to take the limit. So you can see that I can divide everything by n to the 8th power. So we ended up taking the limit of 1 plus 1 over n over 1 plus 1 over n to the 8th power. This is going to go to 0. This is going to go to 0. So we ended up with 1, which is greater than 0. So we know that b sub n, which is this series right here, 1 over n to the 8th power, is a convergent p series. That's because p is greater than 1, so it's convergent. Because the series is convergent, and when we take the limit equals to 1 greater than 0, we know that our a sub n is going to be convergent as well. So we know that this series, our original series, is convergent. To determine whether the series converges or diverges, for this particular series, I want to use the limit comparison test. So if I want to use the limit comparison test, I need to come up with the the series that we want to compare with our original. So our original is going to be a sub n, 8 over n to the first power plus 1 over n. B sub n is going to be 8 over n. So we have to take the limit as n approaches to infinity, a sub n over b sub n. So what I have is going to be limit n goes to infinity, 8 over n to the first power plus 1 over n multiplied by n over 8. So we divide, so we multiply by the reciprocal. Let's rewrite one more time. So you can see that right here, we can write this is as a product, so n times n to the 1 over n power. So if we rewrite one more time, we have 1 over n to the 1 over n power. Let's take a limit of that. Now, recall. So how do I take limit as x goes to infinity, x to the 1 over x power? You can see right here that we have indeterminate. So I'm gonna have to use L'Hopital rule and take care of the limit. So I'm gonna call L as a limit at x goes to infinity, x to the 1 over x power. The reason I have to take care of the L right here because we're gonna have to apply ln to it. So I can bring down the 1 over x right here. So I'm gonna go ahead and do ln. So here I'm gonna take the limit that x goes to infinity, ln x over x. You can see that we have indeterminate. Therefore, we're gonna take the derivative of top and bottom. So if I take the derivative of ln of x, I'm gonna get 1 of x. And then the derivative of x is gonna be 1. So I ended up with 1 over x. So the limit is gonna be 0. So let's go back here. You see that we have limit, we have ln of L right here equal to 0. So how do I get rid of ln? I'm gonna take the exponential on both sides. So the limit is gonna be 1. So going back to our original problem, we know that this limit is gonna be 1. Therefore, we know our series is divergence because b sub n, this series right here, is divergent. This is the harmonic series. So our a sub n, this series, has to be divergent as well.